Hi, welcome to the video on understanding k-means. By the end of this video, you will be able to explain what is k-means, explain how Euclidean distance is used to measure distance between the points in a cluster, explain algorithm behind k-means. In this video, we will be primarily looking at the k-means algorithm for clustering in detail. But let me first give you a brief overview of this algorithm and later we will discuss it in detail. K-means is a centroid based algorithm, or we can say a distance based algorithm where we calculate the distance to assign a point to a cluster. We will be discussing more about these distances and how to assign a point to a cluster later in this topic. In K-means, each cluster is associated with a centroid. So each cluster is defined by its centroid. The main objective of the k-means algorithm is to minimize the sum of distances between the points and their respective cluster centroid. So if you remember the first property of a cluster, we discussed that all the points in a cluster should be similar to each other. This is what k-means tries to achieve. If the intra-cluster distance in a cluster is minimized, there is a high chance that points in the cluster will be similar to each other. So in k-means, we try to minimize this distance. Let's take an example to understand the k-means algorithm. Consider we have these 8 points and we want to apply k-means to cluster these points. First step is to choose the number of clusters. K will represent this number. Second step is to select k points from the data randomly. Let's say we want to have k equal to 2. Then we randomly select 2 centroids from the given number of data points as shown here. Third step is to assign each data point to the closest centroid. As a result, the points which were closer to the red centroid have been assigned to the red cluster, whereas the points which were closer to the green centroid have been assigned to the green cluster. Fourth step is to recompute the centroids of the newly formed clusters. Here, the red and green cross are the newly computed centroids of the clusters. Lastly, repeat steps 3 and 4 until the clusters are formed. But how do we know that after how many iterations the clusters will be formed? There are some stopping criteria for stopping this algorithm. Let's look at them one by one. You can stop the algorithm if the centroids of newly formed clusters are not changing. Even after multiple iterations, if you are getting the same centroids for all the clusters, you can say that the algorithm is not learning any new pattern and it is a sign that you should stop the training. The second criteria that you can look for is if the points belong to the same clusters even after training the algorithm for multiple iterations. Let's say you are training the algorithm and the points are not changing their clusters. So you can stop the training at that point. Finally, you can stop the training if the maximum number of iterations are reached. Suppose if you have set the number of iterations as 100, then the process will repeat for 100 iterations and after that the training will be stopped. The numbers of iterations are usually predefined in the sklearn implementation but can also be changed manually. These are the stopping criteria which helps to decide when we need to stop the training process. So far, we have been discussing from the beginning that k-means measures the distance between the points and the centroid to decide which cluster these points belong to. So the question here is, what exactly this distance is and how it is measuring the similarity between the points. In k-means, we generally use the Euclidean distance to measure the distance between the points and the clusters. Let's now understand how it measures the similarity between the points. Actually, 2 points will only be similar to each other only if their features are similar. Now, if the features of 2 points are similar and we plot these points, then they will be closer to each other. Hence, we can use Euclidean distance, and if this distance between 2 points is less, it means these points are similar to each other. On the other hand, if the Euclidean distance is more, it means that the points are not similar. Let's look at its formula and see how we can calculate the Euclidean distance between 2 points. The formula for the Euclidean distance is given as follows, as shown on the screen. Here, P and Q are the data points. P1, P2, P3 till Pn are the features of P. Q1, Q2, Q3 till Qn are the features of Q. Now, since k-means is a distance-based algorithm, scale of the points can affect the performance of the algorithm. To understand this, consider this data. It has an age variable that tells about the age of a person in years and an income variable that tells the monthly income of the person in rupees. If you look at the age variable, it ranges from 25 to 40 in this case, whereas the income variable ranges from 80,000 to 110,000. Let's try to find the Euclidean distance between the first 2 points. It will be somewhere near to 200,000.000625. You can see that the high magnitude of income affected the distance between the 2 points. This will impact the performance of our k-means model, as it will give higher weightage to variables which have a higher magnitude, that is income in our case. We do not want our algorithm to be affected by the magnitude of these variables, because we are looking for the relative distance between the points. In case we do not cut down the variables to the same scale, the distance we calculate is absolute and not relative. So, what would be the solution of this problem? We can scale all the variables to the same scale. One of the techniques to scale all the variables is normalization. In normalization, we subtract the means of the variables and divide by their standard deviation. Let's see how normalization helps to bring all the variables to the same scale and hence improve the k-means algorithm. In normalization, we calculate the means and standard deviation of the variable. Then, for each observation, we subtract the mean and then divide by the standard deviation of the variable. We will not go into the details on how normalization works, as we have already covered this before. If you want to refresh your memory, please feel free to refer to the topic 4 in module 6, feature scaling technique. Coming back to our example, if we normalize both these features, the result will be like as shown on the screen. Now, again let's calculate the distance between these 2 points. This will be equal to 1.1438. So the distance is not only dependent on the income variable, it is now giving similar weightage to both the variables. So it is always advisable to bring all the features to the same scale before applying k-means or any other distance-based algorithm. That's it in this video. In the next video, we will look at the challenges we might face during its implementation.